You know, in physics, some of the most powerful connections are the ones you can't even see. And today we're going to unpack one of the most fundamental of them all, the incredible unseen link between force and energy. So let's start with a little riddle. What could a falling apple possibly have in common with a cardboard box sliding across a floor? I mean, they seem like totally different things, right? But believe it or not, in the world of physics, they're connected by a very deep and fundamental secret. And here's that secret. In both cases, a force is doing something called work. And when physicists talk about work, they're really talking about one thing: transferring energy. This transfer is what makes things go, what creates all the motion we see. It's pretty much the engine that runs our physical world. And we're about to see exactly how it works. To make this all super clear, we're just going to follow this simple story of a falling ball. Yep, this one little everyday event has everything we need to understand the whole process. Okay, so first up, we need to meet our two key players. Now, before that ball is even dropped, when it's just being held up high, it's already full of what we call potential energy. The best way to think about it is like a fully charged battery. Its height gives it the potential to move. And since it's gravity that's going to make it move, we get a bit more specific and call it gravitational potential energy. And our second key player, that would be kinetic energy. This one's easy. It's the energy of actual motion. The second that ball starts to fall and gain speed, its stored potential energy is being converted into this active, moving energy. So let's just put them side by side to really nail this down. Potential energy is stored energy. It's the promise of motion, just waiting there because of where the object is. Kinetic energy, on the other hand, is motion in action. It's the real deal. So one is waiting and the other one is doing. Which, of course, brings us to the most important question. How does the ball actually make that switch? How does that promise of motion turn into motion in action? I mean, the energy has to get from one state to the other somehow, and there's a very specific physical process that makes it happen. And that process is called work. Now, I know in day-to-day life, work can mean a million things, but in physics, it's super specific. It's what happens when a force is applied to an object and moves it over a distance. And here's the absolute key. Work isn't energy itself. It's the action of transferring energy from one form into another. It's the middleman. So let's put it all together and trace the ball's journey. Step 1, it's held high, not moving, just packed with potential energy. Then, step 2, the moment you let go, the force of gravity is now unbalanced, and it starts doing work pulling the ball down, which leads to step 3. As the ball falls, all that work being done by gravity is actively converting potential energy into kinetic energy, and by step 4, right before it hits the ground, almost all that stored potential energy has been transformed, and the ball is moving at its absolute fastest. But then, thud, the ball hits the ground. It stops dead. All that kinetic energy is just gone. Now, wait a minute. This seems to break a huge rule of physics. If energy can't be created or destroyed, then where did it go? What just happened? Well, the answer is it didn't just vanish into thin air. It couldn't. That would violate a fundamental law of the entire universe. Instead, that energy just changed its costume. It transformed from the really obvious energy of motion into other forms that are a little harder to spot. And this is where other forces get involved. See, even as the ball was falling, air resistance, which is a type of friction, was already stealing a tiny bit of that kinetic energy and turning it into heat. But the big transformation happens on impact. The force of the ground stopping the ball instantly converts that kinetic energy into sound, that thud you hear, and also into heat, which warms up the ball and the ground just a tiny, tiny bit. This whole journey, from the silent potential energy at the top to the sound and heat at the bottom, perfectly illustrates one of the most important rules in all of science, the law's conservation of energy. All it really says is that you can never truly lose energy. You can only change what it looks like. And that's why this is such a huge deal. This isn't just about falling objects. It's about, well, everything. It's the very same principle that lets a car engine turn the chemical energy and fuel into motion, or allows a power plant to turn heat into the electricity that's lighting up your room right now. So, if you take one thing away from this, it should be this. Force isn't just a push or a pull. It's an agent of change. It's what does the work that transforms energy from one state to another. Which leaves us with one last kind of mind-bending question to think about. In a universe where energy is never really lost, just transformed, where does it all end up?